Hello students, welcome to SANKALP CET classes. So today we will be discussing the chapter areas under the curve. Okay, this concept is from application of integrals. So the first point here is the area bounded by the curve y is equal to f of x-axis, and the coordinate axis x is equal to a, x is equal to b is given by a to b y dx, which is equal to a to b f of x dx. So when the area is bounded by x-axis, see the area is bounded by x-axis. So we have a simple figure here for this. Okay, the area is bounded by x-axis, and then we are considering the curve. Okay, this curve. So the area which is bounded by x-axis and the curve, okay, and the lines x is equal to a and x is equal to b is given by a to b f of x dx. F of x is nothing but y. Similarly, when we are considering the area which is bounded by see the curve and the y-axis so when we are considering area bounded by the curve, y-axis, and the line y equal to a and y equal to b, we are using the formula c to d x dy, which is equal to c to d g of y dy. So when it is bounded with respect to x-axis, we are integrating with respect to dx. When the area is bounded by y-axis, we are integrating it with respect to dy, with respect to dy. Next, third point, the area bounded by the two intersecting curve y equal to f of x and g of x. F of x is greater than g of x, and the ordinates are x is equal to a, x is equal to b is given by a to b f of x minus g of x and dx. Okay, so here there are two curves, the first curve and the second curve. So this is the first curve f of x, this is the second curve g of x, and the area between the first curve and the second curve is given by f of x minus g of x. F of x minus g of x within the lines. Okay, within the lines x is equal to a and x is equal to b. So this is the formula a to b f of x minus g of x dx. Next, fourth one, the area bounded by two intersecting curves x is equal to fy and x is equal to gy, and the abscissa. Okay, abscissa is nothing but the x-axis. Y equal to c and y equal to d is given by a to d f of g minus g of y and dy. So here it was ordinate. Ordinate means ordinates is nothing but bounded by y-axis. So here it is bounded by x-axis. Okay, so next point. Next point, area bounded by the parabola y square is equal to 4x and the line y equal to mx. So y equal to mx is a line passing through origin is 8a square divided by 3m cube square units, where a is the constant and m is the slope of the line. Next, area bounded by the parabola x square plus 4ay and the line y equal to mx is 8a square m cube divided by 3. 8a square m cube divided by 3. Next, area bounded by the circle x square plus y square is equal to a square, and the line is given by a square by 2 pi a square by 4 pi minus 2. Area bounded by the ellipse x square by a square plus y square by b square is equal to 1, and the line x by a y by b equal to 1 is given by ab by 4 pi minus 2. ab by 4 pi minus 2. So these are some shortcut results which we can use to simplify the examples directly. So the first example 1, area of the region bounded by the curve y square is equal to 4x, y-axis, and the line y equal to 3. Okay, so we need to calculate the area which is bounded by the curve y square is equal to 4x, y-axis, and the line y equal to 3, and the line y equal to 3. So say y square is equal to 4x. Y square is equal to 4x. It will be a parabola. Y square is equal to 3x. Y square is equal to 4x is a parabola which is opening towards right. And see, this is y equal to 3. This is the line y equal to 3 and y-axis. Okay, y-axis. Okay, so we need to calculate the area which is bounded by y square is equal to 4x and y equal to 3. That is, we need to calculate this area. So to calculate this area, we are using the formula required area is equal to see the y values are changing from 0 to 3 x and dy. From the equation, the value of x is nothing but y square by 4 and dy. So using the equation 1, we can write x is equal to y square by 4. Next, on simplifying it further, we get 0 to 3. See, y 1 upon 4 is constant. Write it outside. Y square can be written as y cube upon 3. 0 to 3. On simplifying, we get 1 upon 4. Y cube value is 27 upon 3. And on simplifying it further, 3 ones are 3 threes are 3 nines are. So 9 by 4 square units is the answer. 9 by 4 square units is the answer. Option B will give us the area which is bounded by the curve y-axis and the line y equal to 3. Next question. Area lying in the first quadrant by the circle x square plus y square is equal to 4 and the lines x is equal to 0 and x is equal to 2 is. Option is a pi, b pi by 2, c the option is pi by 3, and d the option is pi by 4. Okay, so here the equation of the circle is given to us. The equation of the circle, so I'll draw the figure so you understand it. So here there is a circle which is given by the equation x square plus y square is equal to 4. So this is the equation of the circle and this is the equation 1. So we need to calculate the shaded area in the first quadrant. See, the equation of the circle can be written as x square plus y square is equal to 2 square. It is equal to 2 square. So here the radius will be 2 and the point on the x-axis where the circle touches it will be 2, 0. Will be 2, 0. So to calculate the required area, see, we already know the area of circle. The area of circle is pi r square. Area of circle is pi r square. That is entire circle. But we require the area only in the first quadrant. So we are dividing it by 4. So area in one quadrant will be pi r square upon 4. And on simplifying this further, see, a is equal to 1 by 4. We know the value of radius, it is 2. So 2 square. On simplifying, we get 4 pi into 4 upon 4. 4 and 4 will cancel. The answer will be equal to pi square units. The answer will be equal to pi square units. So the option A will be the right answer. The option A will be the right option. Next example, the area bounded by y equal to sine x and y-axis from x is equal to 0 to x is equal to pi is. So here we need to calculate the required region bounded by y equal to sine x, x-axis x is equal to 0 and x is equal to pi. So here in this case the required area will be equal to from 0 to pi. Required area will be 0 to pi. Okay, 0 to pi sine y dx, and value of y see it is sine x. So sine x and dx. So on simplifying this, the integration of sine x is minus cos x. So minus cos x from 0 to pi, and the value of cos x is 0. When x is pi, it is minus 1. Okay, so it will be minus of minus 1 minus cos 0. Cos 0, the value is again minus 1, again minus 1. So outside there is a minus sign. On simplifying, say minus 1 will be minus 2. So minus of minus 2. On simplifying, it will be 2 plus 2. So the option A will be the right option. So first we need to use the formula. Required area will be 0 to pi y dx. Value of y is sine x. Integrate it and substituting the limits, we get answer as 2 square units. So the next example, area under the curve y is equal to sine 2x plus cos 2x between the ordinates x is equal to 0 and x is equal to pi by 4 is x is equal to 0 and x is equal to pi by 4 is. So here the curve is given by sine 2x, cos 2x, sine 2x and cos 2x. So here the required area is given by integration from 0 to pi by 4 y dx. The value of y is 0 to pi by 4. Value of y is sine 2x plus cos 2x dx. So on simplifying this, on integrating sine 2x, we get minus cos 2x upon 2. Now cos 2x integration is sine 2x upon 2. Okay, under the limits 0 to pi by 4. Under the limits 0 to pi by 4. So this will be equal to now. Further, this will be equal to. So once we substitute the limit as pi by 4, see 2 into pi by 4, it will be pi by 2, and cos pi by 2 value will be 0. Sin pi by 2 value will be 1, so it will be 1 by 2 minus, substitute the lower limit 0. So cos 0 will be equal to 1, so it is minus 1 by 2. So it will be minus of minus 1 by 2, and sin 0 is 0. So on simplifying it further, 1 plus 1 it is 2. Okay, and 2 by 2 it will be equal to 1. So the option B will be the right option. Option B will be the right option. So next question, area bounded by y is equal to x square and y equal to 2x is. So here we have parabola and a straight line. So when we have a parabola and a straight line, there is a direct result. So the direct result is y is equal to x square. See, it is a parabola of the type x square is equal to 4ay. X square is equal to y. So when you compare this with standard equation, you get a value as 1 by 4. So if a value is 1 by 4, equation 1 and equation 2 will be same. So when a parabola and a straight line is given, Okay, when a parabola and a straight line, mx I'll consider for time being. So y x square is equal to 4ay is the equation of parabola, and y equal to mx is the equation of line. So when we get this equation 1 and equation 2, the direct answer for y is equal to the area bounded by these two curves, that is the parabola and straight line, is given by 8a square m cube divided by 3. 8a square m cube divided by 3. So now we need to compare these equations. See, this is equation 2, x square is equal to y. So when you compare it with 4a, when you compare it with 4a, you will get the value of a as 1 by 4. And see here, the second equation of the line given is y is equal to 2x. So the equation of line is y equal to 2x. Equation of the curve is y is equal to x square. So m value, in this case, m value will be equal to 2. So a is equal to 1 by 4, m is equal to 2. So the required area is equal to 8a square m cube upon 3. So on simplifying, we get 8. A square will be 1 by 4, 1 by 4 square, 1 by 4 square. M cube value will be 2 cube upon 3. So 8 into 1 by 4 square is 1 by 16, 2 cube is 8 divided by 3. So on simplifying, 8 ones are 8 twos are. So 2 ones are again 2 fours are. So 4 by 3. The right option will be 4 by 3. That is option B. So option B will give us the direct answer. We need to remember this result: 8a square m cube upon 3. Next question: the area of the parabola y square is equal to 4ax, and between the lines x is equal to a and x is equal to 4a is. Okay, x is equal to a and x is equal to 4a is. Okay, so here we have a parabola, and these are the two lines, x is equal to a and x is equal to 4a. So we need to calculate the area between these two lines and the parabola. So we will simplify it. So the required shaded area will be equal to, say, the required shaded area will be equal to RA. The required area will be integral from a to 4a, integral from a to 4a y dx. So y value we are substituting. See, from this equation, value of y will be equal to 2 root a root x. Okay, so this will be a to 4a 2 root a root x 2 root x dx. So on simplifying it further, we get we get, and this is equal to 2 root a is constant, write it outside, x raised to 1 by 2 integral of x raised to 1 by 2 dx. So 2 root a x raised to 1 by 2 x raised to 3 by 2 upon 3 by 2 a to 4a. So substituting the upper limit and lower limit, we get 4a. Okay, 4a raised to 3 by 2 minus a raised to 3 by 2, and this 3 by 2, if we multiply, it will be 2 by 3. Simplifying it further, we get, simplifying it further, see, 2 root a is nothing but 4 upon 3 a raised to 1 by 2 into 4a raised to 3 by 2 minus a raised to 3 by 2. So 4 minus a 4a minus 3a raised to, it will be 3a raised to 3 by 2, 3 into, so say on simplifying, we get, okay, on simplifying, we get here, see when we multiply these and simplify, we get 32a square, 32a square upon 3 minus 4a square upon 3. So on simplifying further, we get 28 upon 3a square. 28 upon 3a square. That is the option C. The right option is the option C. Next question. The area bounded by y square is equal to x cube, the x-axis, y-axis, and the lines y equal to 1 and y equal to 2 is, okay. So here the curve is given by the equation y square is equal to x cube, y square is equal to x cube, or on simplifying we can write x is equal to y raised to 2 by 3. X is equal to y raised to 2 by 3. So the required area will be 1 to 2 x dy, x dy. So 1 to 2 y raised to 2 by 3 dy. So on simplifying, we get the required area is equal to y raised to 5 by 3 upon 5 by 3 under the limits 1 to 2. So 3 by 5, keep it as it is. So 5 raised to y raised to 5 by 3. So value of y is 2. So 2 raised to 5 by 3 minus 1 raised to 5 by 3. So 2 raised to 5 by 3 minus 1 raised to 5 by 3 into 3 by 5. So the option D is the right option. Option D gives us the right answer. Next example, the area bounded by the curve y is equal to root of 16 minus x square is 8 pi units, 20 pi square units, 16 pi square units, or 256 pi square units. So here the curve is given, and directly we can find the answer. So the area bounded by the curve y equal to root of 16 minus x square, y equal to root of 16 minus x square. So y equal to, pay attention, y equal to root of 16 minus x square can be simplified as, see, on squaring on both the sides we get 16 minus x square, or x square plus y square is equal to 16, or x square plus y square is equal to 4 square is equal to 4 square. So x square plus y square is equal to 4 square. So this is the equation of a circle. X square plus y square is equal to 4 square is the equation of the circle with radius is equal to 4. So here the circle is changing from, okay, the circle is changing from 0 to 4. So the required area will be equal to 0 to 4 y dx, or on simplifying we get 0 to 4 integral of 16 minus x square dx. So here we are using the formula integral of a square minus x square, okay, integral of a square minus x square, a special type formula. So using the formula we can simplify it as 2 into, okay, 2 into x square by 2 root of 16 minus x square This we are multiplying it by 2 because the area is bounded both in first quadrant as well as second quadrant. So 2 into x square by 2 root of 16 minus x square plus 16 by 2 sine inverse x by a. Okay, a value is 4, so it will be x by 4 under the limits 0 to 4, under the limits 0 to 4. So on simplifying 2 into so first substitute the upper limit. So when we substitute the upper limit, all the terms will cancel. 4 upon 4 is 1, and sine inverse 1. Sine inverse 1 is pi by 2. Okay, it is pi by 2, and 16 upon 2 it will be 8 pi by 2. 8 pi by 2. And when we substitute 0, first term will be 0 as well as second term will be 0. So on simplifying it further, 2 and 2 will cancel. 8 pi square units. So 8 pi square units, option A will be the right option. Option A gives us the right option. So the next question is on ellipse. Area of the ellipse x square by 9 plus y square by 4 is equal to 1 is. Okay. So here we know the formula for area of ellipse. Okay, area of ellipse, area of the ellipse x square by a square plus y square by b square is equal to 1. Area is given by pi a into b. The formula to calculate area of the ellipse is pi a into b. So when we compare this with the given equation, see, a square is equal to 9, a will be equal to 3, b square is equal to 4, b is equal to 2. So on simplifying, a will be equal to pi into a value is 3 and b value is 2. So 3 into 2 is 6 pi. So the area of the circle, area of the ellipse is 6 pi square units. So the option B is the right option. So we need to remember whenever an example is occurring on ellipse, the formula for area of ellipse is A equal to pi AB. So using the formula A equal to pi AB, we get the area of the ellipse. Next question, the area of region bounded by the parabola y square is equal to x and the line 2y equal to x is. Okay, so the given parabola, the equation of the given parabola is y square is equal to 2x, and the equation of the line is x is equal to 2y. X is equal to 2y. So when we draw the figures for these two curves, that is the line and the parabola, we get a parabola. The parabola is opening towards right. The parabola is opening towards right, and the line is intersecting. See, line is of the form x is equal to 2y. It is a line passing through the origin. It is the line passing through the origin. Parabola. Okay. And the line y, x is equal to 2y. So you get the line x is equal to 2y. So the point of one of the point of intersection is 0, 0. Another, when we solve these equations, y equal to 2x and x is equal to 2y. This is y square is equal to 2x. So we get the point of intersection as 4, 2. Okay. The other point of intersection will be 4, 2, and on x-axis the point will be 4, 0. So we need to calculate the area which is present between the area which is present between the parabola, and the line. Okay, and the line. So this is the required area we need to calculate here. So to calculate the required area, we need to take the difference between the two curves areas. So the required area will be equal to, see, integration from 0 to 2, root x minus, root x minus integration from 0 to 4, 0 to 4 root x minus x by 2 dx. So this is the parabola, and this is the equation of the line. Okay, so y square is equal to x is the parabola, x is equal to 2y. On simplifying, we get root x minus 0 to 4 x by 2 dx. So simplifying these two areas, these two integrals, we get the required area. So the required area is equal to root x. Root x will be x raised to 1 by 2. Integral will be 2 by 3 x raised to 1 by 2 under the limits 0 to 4 minus 1 by 2 is common, x square upon 2 under the limits again 0 to 4. So on simplifying, we get 2 by 3, 4 raised to 3 by 2, minus 1 by 2, 4 square, is 16. So on simplifying it further, we get 16 by 3 minus 4. So it will be equal to 4 by 3 square units. So the option A is the right option, 4 by 3 square units. So here we have used the area between the two curves, that is area between the parabola and the line. The next question is the area enclosed between the parabolas y square is equal to 4x and y square is equal to x square is equal to 4y. Okay, so observing the equations, the one of the equations of the parabola opening right side and another is opening upwards. So we need to calculate the area present between the two parabolas, and that is we need to calculate this particular area which is present between the two parabolas. So to calculate the areas between the two parabolas, we are using the direct result. So if equation of the two parabolas are y square is equal to 4ax and x square is equal to 4ay, then the area between the two parabolas is given by 16a square upon 3. 16a square upon 3. So this is the direct formula to calculate the area between the two parabolas. So here we require the value of a. See, the value of a in both the cases, it is equal to 1. So a is equal to 1. So using the formula, a will be equal to 16 into 1 square upon 3. Or on simplifying, we get 16 upon 3. 16 upon 3. So the option C is the right option. Option C gives us the right option. Next question. Area enclosed between the curves y is equal to ax square and x is equal to ay square is 1 square units. And then a is equal to, then a is equal to. So first we are using the result here. If the equation of the curves is of the type, y square is equal to 4ax, and x square is equal to 4ay. X square is equal to 4 by, okay, by, and then area is given by 4a into 4b divided by 3. 4a into 4b divided by 3. So using this result, that is 4a into 4b divided by 3 to the equation 1. See, the equation 1 can be written as x square is equal to 1 by a into y, and the second equation can be written as y square is equal to 1 by a into x. So in place of 4a, we have 1 by a. So the required area will be equal to, say, 1 by a into 1 by a divided by 3. 1 by a into 1 by a divided by 3. But in the question itself, they have mentioned a is equal to 1. So a is equal to 1. 1 by a into 1 by a is 1 by 3a square. On simplifying, 3a square is equal to 1, or a square is equal to 1 by 3. A is equal to 1 upon root 3. So the option A is the right option. So whenever two parabolas are given, so if their A terms are same, then you can use A into A, 4A into 4A. But when A terms are different, so we are using the for result 4A into 4B upon 3. Replacing 4A values, when you compare this first equation with this equation, you will get in place of 4A, we have in place of 4a we have 1 by a. Here also in the second equation, in case of 4b, 4b, in case of 4b, why it is, so in case of 4b, 4by, so in place of 4b also we have 1 by. So substituting and simplifying, we get a is equal to 1 upon root 3. A is equal to 1 upon root 3. Next question. Area bounded by y equal to log x, the x-axis, and the line x is equal to 2 is, and the line x is equal to 2 is. So here in this case, the required area A equal to, the required area A is equal to, the required area A is equal to y equal to log x. So you can write it as y and dx. The limits are from 1 to 2. So y is y-axis, so y-axis it will be 0. So 0 to 2 will be the limits. 0 to 2 will be the limiting values. Okay. So on substituting, we get here x is equal to 2, one value is given, and they have given another value as y-axis. They have given the other value as x-axis, and we know x-axis y is 0. So the other value we get is 1. So here we are making use of the given equation to us. The given equation is y is equal to log x. Y is equal to log x. So when y is equal to 0, okay, log x, x will be equal to 1. So one of the limiting value will be 1, another limiting value will be 2. Substituting the value of y in the equation, we get 1 to 2 log x and dx. So the integration, we are applying by parts and simplifying it. Integration by parts, so it will be integration of 1 into log x and dx from 1 to 2. So on integrating by parts, okay, integrating by parts, the first function will be log x, integration of 1 will be x minus integration of again 1 will be x, and derivative of log x will be 1 by x and dx. So x and x will cancel off. We get x log x minus 1 integration will be x. On simplifying, it will be x log x minus 1. Okay, integration from 1 to 2. Integration from 1 to 2. So required area will be equal to, first we need to substitute 2. So it will be 2 log 2, 2 log 2, 2 log 2, 2 log 2 minus 1 into x. It is. So better I will consider this as the equation. So the simplification will be easy. So in this equation, we are substituting 2. Where there is x, we are replacing it by the upper limit. So the answer will be here 2 log x minus 2. This will be the first part. And in second case, log 1 we know it is 0. Log 1 is 0. Log 1 is 0. Minus 1 and minus of minus 1. Minus of minus 1 it will be. So on simplifying, we get 2 log x minus 2 plus 1. On simplifying, 2 log x minus 1 will be the final answer, and the required area will be given by the option D. So option D gives the right answer. Question: the area of the region bounded by the curve y equal to x square and line y equal to 16. So y equal to x square is again a parabola opening upwards. So the figure for this particular curve will be a parabola which is opening upwards. 1 minute. So here we have x-axis, y-axis, and this is the curve which is opening upwards. This is a parabola which is opening upwards, and this is the line y is equal to 16. So we need to calculate the area which is bounded by the curve, x-axis and y equal to 16. So this entire area, and you can see this entire area, it is actually symmetric. It is symmetric along y-axis. So I'll be calculating the area in the first quadrant and multiplying it by 2. To get the required answer. So a required area will be equal to x dy from 0 to 16, and since it is symmetric, it will get multiplied by 2. So x square is equal to y. X will be equal to root y. So 2 times 2 to 16 root y and dy. On simplifying, root y is nothing but 2 raised to 1 by 2, and y raised to 1 by 2. It will be 3 by 2 into 3 by 2 under the limits 0 to 16. So on simplifying, we get 2 into y raised to 16. This will be 2 by 3 y raised to 16. That is 16 raised to 3 by 2 minus 0. So on simplifying, we get 4 upon 3, and 16 raised to 3 by 2 is again 16 raised to 3 by 2 is 64. Okay, 64. So 64, and on simplifying, we get 256 upon 3 square units. 256 upon 3 square units. So the option B will be the right option. The area enclosed between the curves y equal to x cube and y equal to root x is in square units 5 by 3, 5 by 4, 5 by 12 and 12 by 5 and 12 by 5. So again we need to calculate the areas between the two curves. So the first curve is y equal to x cube, and the second curve is y equal to root x. If we square this on both the sides, okay, see when we equate, we get x cube is equal to root x. So squaring on both the sides, we get x raised to 6 is equal to x. Or on simplifying, we get x raised to 6 minus x is equal to 0. Or x raised to 5 minus 1 equal to 0. So x is equal to 0 or x is equal to 1. So we need to calculate the area between these two curves. So the required area will be equal to integral from 0 to 1 root x minus x cube dx. So on substituting and simplifying, we get root x integral will be 2 by 3 x raised to 2 by 3 x raised to 4 upon 4 under the limits 0 to 1. Under the limits 0 to 1. So 2 by 3, when we substitute 1 raised to 2 by 3 is 1, and this will be 1 by 4. And on simplifying it further, we get 5 by 12. So the option C is the right option. Option C is the right option. So the next example is the area bounded by xy equal to 1, x is equal to 0, y equal to 1, and y equal to 2 is. So here the given curve is xy is equal to 1, or we can just write it as x is equal to 1 by y. So using the definition, calculate the required area. So the required area will be from 1 to 2 x and dy. So 1 to 2 x value is 1 by y and dy. So on simplifying, we get required area is equal to log y from 1 to 2. So this will be log 2 minus log 1. Log 1 value is 0. So the final answer will be log 2. Final answer will be log 2. Option C. Next example, the area bounded by y equal to x square minus 7x plus 10 and x-axis is 5 by 2, 11 by 3, 9 by 2 and 3 by 2. So the equation of the given curve is y equal to x square minus 7x plus 10. So if we simplify, x square minus 7x plus 10 equal to 0. The factors will be x is equal to 2 and x is equal to 5. So on simplifying the quadratic equation, we get x is equal to 2 and x is equal to 5. So the required area will be from 2 to 5 y dx. On simplifying it further, the required area will be equal to 2 to 5. Value of y is x square minus 7x plus 10 dx. On simplifying, we get x square integral is x cube upon 3 minus 7x square upon 2 plus 10x under the limits 2 to 5. Under the limits 2 to 5. So on simplifying, we get First we need to substitute the limit 5. So it will be 125 upon 3 minus 5 square is 25 into 7. It will be 175 upon 2 plus 50 minus replace by 2. So 8 upon 3 minus 2 square 4. It will be 28 upon 2 plus 20. So on simplifying the values, we get a minus 9 by 2. The modulus value of minus 9 by 2 will be plus 9 by 2. So the required answer is C, 9 by 2. Next question. The area of the region bounded by the curve y equal to sine x between the ordinates x is equal to 0 and x is equal to pi by 2 and the x-axis is so here the given curve is y equal to sine x. So the required area will be required area under this curve under the limits 0 to pi by 2 y dx. This will be 0 to pi by 2 sine x dx. Integration of sine x is minus cos x 0 to pi by 2. 0 to pi by 2. So cos pi by 2, the value will be 0 minus 1. So on simplifying we get plus 1. Option D is the right option. Option D gives us the right option. Next question. The area of the region bounded by the curve x is equal to 2y plus 3 and the lines y equal to 1 and y equal to minus 1 is. Okay, so again we need to calculate the required area. So the required area is given by x and dy under the limits minus 1 to 1. So the value of x is 2y plus 3 dy under the limits minus 1 to 1. So on simplifying it further, required area will be equal to y square plus 3y from minus 1 to 1. And on simplifying we get 1 plus 3 minus 1 square is again 1 minus 3. So 4 plus 2 which is equal to 6 square units. Option C is the right option. So the next question is area bounded by y-axis y equal to cos x, y equal to sin x under the limits x greater than equal to 0 less than equal to pi by 4 is. Okay. So here we are considering x-axis, y-axis, x-axis, y-axis. Next, equation of the sine function. So this is the curve which indicates sine function, and then equation of cos function. So cos function at 0 it is 1. Okay, so the curve will be somewhat like this. Okay. And see here we need to calculate the area which is bounded between these two curves. Okay, these two curves, that is we need to calculate this particular area, the area which is bounded by between sine curve and the cos curve, sine curve and the cos curve. So this is the sine curve, sine x, and this is the cos x, x-axis, y-axis. So we need to calculate this area present under 0 to pi by 4. Okay, 0 to pi by 4. So the required area will be equal to 0 to pi by 4 cos x minus sin x dx, sin x dx. So 0 to pi by 4, 0 to pi by 4 cos x. I'll directly integrate it now. Okay. So when we directly integrate this, we get, on integrating, we get cos x integration. Integration of cos x is minus sin x, and sin x integration is minus cos x. So minus of minus, it will be plus cos x. So sin x plus cos x under the limits 0 to pi by 4. So on substituting and simplifying, we get 1 by root 2, 1 by root 2 plus 1 by root 2 minus 0 plus 1. Okay. So 1 by root 2 plus 1 by root 2, it will be root 2 minus 1 square units. So the option B is the right option. Option D is the right option. So these were few examples on application of integration. So the examples based on parabola, areas between the parabola and line, areas between the curve have been asked from CET point of view. So you can practice these examples and some examples from the question papers. Thank you.